Hello everyone, today we'll talk about the solution to the problem number complement. It's a nice, easy problem compared to yesterday's hard DP. We have to take the number and disregard its leading zeros, just flip all the ones to zeros and zeros to ones. Now, when it comes to situations where you have numbers and when you have binary representations of numbers, it's useful to not think of those two things as two different things, so two different domains. Sometimes you do bitwise operations, sometimes you do arithmetic operations, but it's also nice to see where those two domains meet, because that makes sure that you understand how you can use binary operations, but also how you can use the arithmetic operations, what they actually do on bits. And this is a nice introductory problem where there is a very easy arithmetic interpretation of what we're doing here. That's because if we have a number and we disregard its leading zero, so it starts with a 1, so let's say something like this. If we want to flip all its bits, we get something like this. And what can we say about this? Well, one thing that we can easily notice is that when we add them together, we get all ones. So one easy way of getting this number would be to start with this number and subtract this original number. Okay, so what is the number that is our original number, but everything is a 1, not counting, of course, the leading zeros? Well, we're not sure about that, maybe, but what we know is that if this number, we were to add 1 to it, we would get a 1 here, and all the rest would be zeros. So what is a number that starts with a 1 and has all the rest being zeros? That is a power of 2. And which power of 2 are we interested in? Well, we want that 1 to be right to the left, so straight to the left of the leftmost one in the original number. So the smallest power of 2 that's greater than the original number. It's easy to find that power of 2. We don't actually have to do any tricks when it comes to binary representation. We can just start with 1 as the candidate power of 2. And while our power of 2 is not greater than the number, we can multiply it by 2. Of course, that's one way of looking at it. Getting the next power of 2 is multiplying by 2. But really we want to start with this 1 over here and push it to the left until we clear our number. Until the number with 1 and all the rest being zeros is greater than the starting number. To shift the number to the left, when it comes to a single 1, we just shift the single 1 to the left. We can just write this bit shift symbol, which really represents shifting bits. It also leads to this nice, cute representation of here less than or equal, and here we have left shift equals 1. But we shift it one position to the left until it becomes bigger than the number. And then, of course, we know that this number, this power of 2 minus 1, minus the number is this complement that we're being asked to generate. There are, of course, many other solutions to this problem, but this one is nice in that it both showcases bit shifts as equivalent to multiplication or division by 2, and also that we can combine arithmetic thinking and bitwise thinking in problems, and it's useful because it leads to deeper understanding of both of those approaches.